Hi, I'm Angie Jones. I'm a Java champion and principal developer advocate at Tools, and I love Java. I teach free courses at Test Automation University, including a Java programming course, Selenium WebDriver with Java, visual testing with Java, and others as well. While Java is still the leading programming language, it's gotten a bad rep over the years. Some of the biggest gripes that I've heard are things like Java is too verbose, meaning we have to write a lot of code to do the most basic things. Another gripe I've heard is that the language isn't evolving fast enough. Well, yeah, the releases of Java 7, 8, and 9 were all 3 years apart, which is almost a lifetime in software development time. Fortunately, the powers that be have heard us loud and clear, and Java has gotten a much needed makeover. And now, new versions of the language are being released every 6 months. With so many new features, it can be hard to keep up. So, in this talk, I want to demonstrate some of the newer features of Java and how we can take advantage of them within our code. We're going to look at some test code for verifying this banking page. And the specific test we'll go over today is just going to make sure that all of the accounts here are actually listed. So here's our test code, and let me walk you through it. Here, we're logging into the application, and we get a handle to this accounts overview page. So this is where that table of accounts is located. Next, we get a list of the account numbers that are displayed on the page, and then we want to get the expected accounts. So this test data can change, so we're actually going to make a call to an API to get the expected accounts, and this returns a list of deserialized account objects. So we want to make a new list, which will only contain the account numbers as strings, as opposed to the entire accounts. We loop through the list of account objects, and we add the number from each account into our list of expected accounts. Finally, we compare both lists to make sure that every account for this customer is actually shown on the site. Now, this test was written in Java 8, so let's go through it and see how we can modernize it using some of the latest features in Java. Let's start here with the declaration of the accounts overview page. As you can see here, we're following Java conventions. We're using good names for both our class and our object. However, many times, as we see here, these two names are the same thing. So this is redundant, right? It makes for a lot of typing. So in Java version 10, type inference for local variables was introduced. And what this means is that instead of explicitly declaring the object or variable's type, we can instead use this keyword var. And Java will infer what the type is based on what's being assigned to it. This is my favorite new feature in Java because, especially in test code, we always have these long names for our page models, and now we no longer have to type them all out. But before you get carried away and start using var everywhere, let me explain the rules and also give some tips. This does not make Java a dynamically typed language like JavaScript or Python. The type is still there, it's just inferred from the right-hand side of the statement, which means you can only use var if you're actually initializing the variable. Otherwise, Java's not going to be able to infer what its type is. Also, it only works for local variables. You can use this inside of methods, loops, decision structures, but you cannot use this for global variables, even if you are initializing them. While local variable type inference can be used within the body of local constructs, it can't be used in the headers of methods or constructors. And this is because if you think about it, whoever's calling you, they need to know the data type, right, of the arguments that they need to send. Okay, so those are the rules. Now let's get into some guidelines. Given this variable name and the method name, I have no idea what the inferred data type of X would be. Sure, Java knows, yeah? But me as the reader, I can't easily tell what this is. And that makes it really difficult to work with this variable. So you should always use good variable names, but it's even more important if you're going to use var. Now, once you get started using var, you're going to love it. But please don't overdo it. Using var in this instance doesn't do you any favors, right? Var is 3 letters, int is 3 letters. Just type int. No need for all the drama and mystery here. Just type int. Okay, so I've updated our test method to use vars. So I'm using var here, and the inferred type is very clear to me as the reader because of the variable name that I chose. However, here I had to change the variable name from actual accounts to actual account IDs list. And I say had to, but really I changed it so that it's clear to me that this is a list and it's holding the account IDs. So you see how even with a good variable name, when you use var, there could be a little bit of ambiguity. So it's best to make sure that the variable names are crystal clear. For this one, I also changed the name from accounts to accounts list so that it's clear that this is a list holding account objects. Here, I changed the name to be more representative, and I also explicitly defined the data type of the array list on the right-hand side. Now, if I didn't use this diamond operator to indicate that this is a list of strings, then it's going to be inferred as a list of objects. And that's okay in this case, but it could get us in trouble down the road. For example, if I need to get one of the string elements from this list and I need to do a dot operator and I'm expecting to have access to the string methods, I wouldn't have that because Java would have inferred this as a list of objects, not a list of strings. So just to be safe, you can use the diamond operator there. And then here, I'm using var inside of a for loop just to show you that it can be done. Okay, let's see what else we can modernize. How about let's take a look inside of this getAccounts method. Remember, this is the table, and we're getting all of those values in the first column labeled accounts. And here's the code to do so. So we see here, it finds all of the account cells, and these are web elements. Then it creates a new list to hold just the text of the web elements. So this is a list of strings. And to populate that list, we loop through each of the elements from line 3. We get their text, and then we add them to our new list from line 6. Notice this method needs 2 lists and a loop. So, of course, there's a more modern approach to do this in Java by using functional programming style. So this approach was actually added in Java 8, but I don't see it used much in test code. So I wanted to highlight it quickly. Now, as you can see, this is much more streamlined. Here, we still call find elements to get the list of web elements, but we don't need to store them. Instead, we turn them into a stream from which we can do some cool functional programming. This map function will take those web elements and map them into whatever is passed into this. So here we're saying get the text from these web elements and then store them into a list which we return. Now here's an alternative way to write the map call. Notice in the top example, line 5 uses a shortcut or a syntactic sugar, and in the bottom example, line 3 uses the fully spelled out approach with the lambda arrow. Now we can do the same in our test method. So instead of using the to list in a for loop, I use a stream and a map to get what I need into a single list. Now, it's a good practice to break up these chained method calls where each method is on a new line. I know. It's really tempting to do this big, powerful call all on one line because it's like, wow, look at this wicked one-liner, right? But it makes it harder to read your code and process what it's actually doing. So it's a good practice to break it up so that each call is on a new line. Also, a lot of the editors I know, IntelliJ, for example, if you break it up this way, you can put breakpoints on the different nested method calls. So that's pretty cool. All right, let's look at what's new with streams. So Java 9 introduces a couple of new methods to stream, one being takeWhile. So let's say I have this code which gets the list of accounts and then uses the takeWhile method on this stream of accounts. Within this takeWhile method, you pass in a condition, also known as a predicate. And this is saying to go through this list of accounts and accept all of the ones that have a type of checking until you get to one that does not have this type. So here are all the accounts stored in accounts list. Notice there are 11 of them. And when we say takeWhile type is checking, we end up with a list of 3 accounts. And as you can see, it's the first 3 accounts from the accounts list. But when we got to the 4th account, the type was savings. So the stream ended. Java 9 also introduced dropWhile, which does the opposite of takeWhile. For this one, we're saying drop the accounts of type checking until you get to one that's not. So with 11 accounts here, we see the first 3 are checking, the 4th is savings, the 5th through 9th are checking, the 10th one is savings, and the last one is checking. So take a moment. How many accounts do you think will be collected here in checking accounts list? All right. If you said 8, you are correct. So this method dropped the first 3 accounts because they matched the predicate, and then it stopped the stream. So all other accounts are collected and stored into the list. So all of the accounts couldn't fit on the last slide, so here's the full list of dropWhile account type is checking. So you might be thinking, why on earth would I want to use takeWhile and dropWhile, right? The examples I showed you were a bit of a brain tease. That's because the lists weren't sorted, so the results were indeterministic. However, if you sort the collection first, as we're doing here, it makes a lot more sense. And notice I'm using this comparator to specify which property I want this object sorted by. So given the sorted list, we see that it collects all of the checking accounts, and that actually makes more sense. Likewise for dropWhile. Okay? All right, let's see what else we can modernize. How about let's look inside of this get customer ID method. So this method is holding our test data, and based on the name on the account, it's returning the account ID. So this is using switch statements. And notice we have to declare the variable. Then we specify each case we want to handle. And inside of the case, we assign the value to ID. And then we must follow the assignment by a break statement to prevent fall through into the next case, which would override the variable. Okay? Funny thing about fall through, if you forget that break statement, I'm sure all of us in the room have had this happen before where you had an oopsie moment, you forgot a break statement, and you got the wrong value returns back, right? Yeah. So, risky. This is risky. It's not only a lot of boilerplate code, but again, you forget one of those things, and now all of a sudden you have this bug. In Java 12, switch expressions were introduced. Now you can use switch to directly assign a value to a variable. So notice here, we're using switch on the right side of a statement to initialize a variable. So the case statement doesn't need a colon in switch expressions, but instead it uses an arrow. And this is saying if the name is John, then assign 12212 to the variable ID. Notice, I don't need a break statement. Woo! There's no fall through with switch expressions. And I can even simplify this a bit more by removing the assignment here and just returning the result of the switch expression. Now, using the lambda style arrows is one way to assign the value, but you can also use another approach. You can use the colon that we're used to, but if you do, you need to follow it with the word yield. So yeah, this is a bit more verbose, so I actually prefer to just use the arrow. You can also specify more than one case. So this gets you around that limitation of removing fall through. Because while fall through is a pain in our side sometimes it's actually useful, right? When you have more than one case that you'd like to address with a single block of code. So notice here, we're saying if the customer name is John or Demo, which is his last name, then the ID is 12212, right? So again, this makes up for the removal of fall through from switch expressions because now you can indicate all of the cases delimited by a comma. You can also do more than just assign values. For example, here we're using the lambda style arrow followed by a set of curly braces to indicate we want to do more here, right? And inside of the body of this case, we can add more statements like this one, but the last line of the case must yield a value to be returned, right? Because think about it, the switch expressions, these are meant to be assigned to something, right? So do whatever you want to do, all of the statements you want, but at the end of this, don't forget that assignment because that's what switch expressions are for. Okay, let's talk about the rules. You'll need to use the arrows or the colon yield. You can't use both. You can't like mix and match it, right? So line 3 would give you a compilation error because it's a different kind of case. Now you can use the yield with the arrows, but only in the events like the last one I showed you where you're using the curly braces to execute multiple statements within a case. You can use any of the cases to throw an exception. So, of course, in this case, no value is going to be returned for ID because the entire flow is interrupted by the exception. Now, I'm using it in this example for the default case, but you can throw an exception from any of your cases and also from multiple cases. So I could also throw an exception for case Mary. I could throw a different exception or the same one. You can do what you want here. Now, this is not a replacement of the switch statements. It's an addition to the language. And what that means is you can still use switch statements, and in some cases, it's probably the more favorable option. So as a rule of thumb, use expressions when you're using a switch to assign a value, and use statements when you're not using switch to assign values, but just to invoke statements. Okay? All right. Let's go back to our test. So what else can we modernize? How about we go into this getAccounts method, which is an API call. So this method is making a get call to get all of the accounts for the specified customer. And it's then deserializing the response into an array of account objects. Okay, let's look at the API response for this call. So notice here we have an array of these account objects. And each account has an ID, a customer ID, the type, and the balance. So I have this Pojo class that has nothing but these fields as well as the getters and the setters. And for any of you who have created Pojos, which are plain old Java objects, meaning they just hold some fields and some getter and setter methods. For any of you who've created these, you know that this is a tedious thing to do. And many people have moved to using the Lombok external library so that they don't have to write all of this boilerplate code. But hold on to your seats. In Java 14, a new construct has been added called records. This is a record, my friends. Much, much shorter, right? Notice here, instead of using the word class, we use the word record. Also, as opposed to opening this with a curly brace, we use parentheses to declare the fields. You specify the fields and their data types in this comma delimited list, and then you close it with a closing paren and a set of curly braces. And that's it. You don't need to make any getters and setters. You don't need to override the inherited methods of equals and hash code or toString. Nope. All of this is just done for you, and it's done quite nicely. However, if you just want to override anything, you can do so within the curly braces. So just open those curly braces up and knock yourself out. You can add any new methods you would like to in here. You can also override the inherited ones from objects. Records can be instantiated just like classes. So account is the name of our record, and we use the new keyword and invoke the constructor, passing in all the values. So just like we would do with a class. The fields, however, of a record are final. So there are no set methods generated for records. Of course, since you have that set of curly braces and I say you can do what you want, you can add setters within the curly braces of a record, but I don't really see a good reason to do that since the fields are final and they can't be modified anyway. Now you do have your accessor methods. However, they don't start with the word get. Instead, the accessor method name is the same as the field's name. So notice here we have account.balance versus account.getBalance. Now, records were released as a preview feature in Java 14, which was released in March of this year. And what that means is it's not yet a permanent feature of the language. It's just available for us developers to play around with and offer feedback. And then based on that feedback, the implementation can change. So, bottom line, don't use records in production code just yet until it becomes a permanent part of the language. That also means that support from external libraries might not be available just yet for preview features. For example, the Jackson library is used to deserialize that JSON response into this record. However, when I was playing around with this, the Jackson library didn't officially support records yet. So, as a hack, you'll need to explicitly bind each field to its respective JSON property. And then when and if records becomes permanent, I'm sure the Jackson project will provide support. They may have already. I think I saw a tweet that they were starting to add some support. So the explicit binding might not be required anymore. I haven't tried it out since they started adding stuff. But you get what I'm saying. You might have to tweak some things, or your favorite external libraries might not support the preview features. Okay, next I want to show you text blocks. So let's continue on with the API. What if instead of calling the API, we instead wanted to mock the data right there in this API util class? To represent this whole thing as a string would be very tedious, yeah? We need to escape all of the fields because they were already in quotation marks. We need to add new line characters for each line break, and we need to add the plus signs for each line. This is ugly to read, it's ugly to write. Yeah, nobody wants to see this. Text blocks. Mwah. Text blocks allow you to use 3 quotation marks to open and close a big block of text. So notice you don't need to escape anything. The individual quotation marks are still there on the fields, and the line breaks are respected. So text blocks were introduced in Java 13 as a preview feature. We got a second preview in the latest release of Java 14, and then Java 15, which has also been released, makes this a permanent feature. So yay, welcome to Java text blocks. We're so glad you're here, right? All right, let's look at some rules and some guidelines for text blocks. You cannot include the entire text block on the same line, or you're going to get a compilation error. A new line must be after the opening quotes, like in this second example here. And this is legal, but it's not the preferred way. Looks a little bit goofy, right? Little bit unbalanced. The preferred way is to have both the opening and the closing quotes aligned on their own separate lines, right? So I had to fit all of this on one slide. That's why you only see one line of text here. But don't do this, y'all. Don't put one line of text in text blocks. Use a string for that. But when you have the big block of text, this is how you would use it. Put your 3 quotation marks on its own line, and then your 3 closing, and kind of have them aligned. And so that makes it more readable. All right, one more thing I want to show you in that API class. Let's say that we didn't want the entire response, but we wanted to just return a hard-coded list of expected account IDs. The old way of doing this would be to use the arrays.asList method. However, in Java 9, this of method was introduced for all entities in the collection framework. So lists, maps, sets, etc. This one seems small, but I've actually really been enjoying it. And I think the reason for that is that it's more natural, right? Before, it took like this slight cognitive effort to recall, which class do I use to make a quick list? Is it arrays, plural? Like, which one is it? But now, I want a list, I call list.of. I want a map, I call map.of. Nice and straightforward. And speaking of maps, populating these required a separate method call for each item that we wanted to add to the collection. Now you can define a map all with one line of code. So the parameters are key followed by value, and you see here we have 3 entities in this one line. All right, so I got the one-liner out of my system just to show you, but I don't actually recommend you do it like this because it's kind of easy to get confused here on, which key is associated with which value. So in real life, I would put each one of these pairs on its own line, but it's still just one call, the map.of. Okay. So one thing to note about using the of method is that it creates collections which are immutable. What this means is that the collection cannot be changed by adding, removing, or sorting it later. So only use this when your collection won't require any changes later in the program. All right, so there you have it. These are a few of my favorite new features from recent versions of Java. I've been using them in different projects, and I find them quite useful, even for test code. Thank you so much. What questions can I answer?